In this video, we will do another example involving the quotient rule and product rule. All right, so the example is let g of t be the function t cubed plus 4 all over t squared e to the t. And I want to find g prime. I want to find the derivative. So I want to have you all pause the video for about 3 minutes to try this on your own first. So pause the video in 4, 3, 2, 1. Pause the video. Pause the video for 3 minutes and really try this problem. This is a really good, higher difficulty problem than the ones that we've seen before in this section. So it's really good practice to pause the video and try this on your own and see how well you can apply things like the quotient rule or the product rule. All right, so hopefully you've done that. Hopefully you paused the video for about 3 minutes to try this. If not, go ahead and do so now. Go ahead and pause that video for about 3 minutes to try it. All right, so let's talk about this. Let's talk about it together. So with this function, I need to use the quotient rule. So we need to use the quotient rule because I see a function on the top, I see this function on the bottom, so we are going to need to do quotient rule with this. So doing quotient rule, I get g prime of t, my derivative, is low t squared e to the t, that's the bottom function, low, as we call it sometimes, times d high, derivative of the top, so d dt of t cubed plus 4. Notice I'm writing d dt because my variable is t in this problem, it's not an x. Okay, so I got low d high minus high, which is t cubed plus 4. We've got to make sure we put that parentheses around it, otherwise I might forget to distribute this negative sign. Okay, so minus high, d low, so times the derivative of low, or the bottom, t squared e to the t. Okay, so that's the numerator from the quotient rule, and the denominator is low squared, or the bottom squared, t squared e to the t, that whole thing being squared. Okay, so there are a couple of derivatives left for me to figure out. So there is this derivative of t cubed plus 4, and that one's not too bad. But there's one more derivative. I have to do the derivative of t squared e to the t. So pause the video one more time for about 20 seconds and just think about what rule we would need to use to take the derivative of t squared e to the t. 4, 3, 2, 1, pause the video. Pause the video for about 20 seconds to think about what derivative rule do I need for that function. All right, so hopefully you pause the video for about 20 seconds to think about that. Okay, so this is two functions multiplying each other, t squared times e to the t. It's a product of functions. So we need the product rule to handle that derivative. Okay, so let's start to do this. So I'm going to rewrite the beginning. So we have g prime of t equals, we have t squared e to the t multiplied by, so the derivative of t cubed is 3t squared, and 4 is a constant, so its derivative is 0. And then we have minus, we still have that t cubed plus 4. And now we're going to need to do a product rule in this last parenthesis. So I'm going to give myself a big bracket here so I can write down all the terms that show up from the product rule. So remember, the product rule is the first function, t squared, times the derivative of the second, so times the derivative of e to the t, plus the second, so plus e to the t, times the derivative of the first, so times the derivative of t squared, the derivative of the first. Okay, so that, everything in that bracket is now what we get from the product rule. First function times the derivative of the second, plus the second function times the derivative of the first. All right, so we have this whole thing over the denominator, which was t squared e to the t being squared. So remember, that's what we got from low squared. That's what the denominator is when we do quotient rule. Okay, so now there are these two derivatives within the product rule that I need to evaluate. So we have g prime of t equals, so everything at the front, I can simplify it a little bit. 3t squared times the t squared in front is going to be 3t to the fourth, and we have that times e to the t. And then minus, and then in parentheses we have t cubed plus 4. And then within the bracket we'll have t squared times the derivative of e to the t. We've seen before that that's just itself. So the derivative of e to the t is just itself. And then we have plus this other e to the t times the derivative of t squared. And the derivative of t squared is 2t. So maybe let me write that as, let's put the 2t in front of that. And then I'll put the e to the t after. Okay, and then I'll close that bracket. And then this whole thing over the denominator, which was t squared e to the t, that quantity squared. Okay, and at this point, I have finished doing all the derivatives that showed up. So we did a quotient rule step in the beginning. So when I said we did a quotient rule, technically we're doing quotient rule first, and then later within that quotient rule, we ended up doing a product rule. So both the quotient and the product rule showed up in this problem. And that's part of what makes it a really great example, because we're practicing applying multiple concepts that we've seen to a new problem. All right, so let's box this. So being able to apply different concepts to tackle new problems, like we did in this example, that's one of our course goals. And that's one of the reasons why it's super important to pause the video and actually try these problems during these pauses that we have built into the videos. Because that gives us a chance to practice this skill, practice developing this ability to apply different concepts, to think back, apply them, and see how we can use them to tackle a new question. All right, so we have now talked about the quotient rule and the product rule. Next time, so in the next video, we will learn a rule for the derivative of a composition of functions. So that's when I have a function inside of another function. So something of the form f of g of x. So we'll learn a rule to handle derivatives like this.